So dear students, in this class we will learn the basics of engineering drawing. In the basics of engineering drawing, first we need to learn different types of lines. First one is the continuous line. This is continuous line. In the continuous line, where we can use this continuous line. This continuous line is used to represent the boundaries of an object or outer profile of an object, or if you want to represent different borders of a drawing sheet or visible lines, if you want to draw, those lines are represented with continuous line. Line, what we can use, continuous thick line, this is continuous thin line. Continuous thick line is used for drawing of borders, outer profiles of the object and visible lines. Okay. Now continuous line, but it is thin line. Second line is the continuous line, but it is thin line. The thin continuous line used for drawing the constructional lines. That means if you want to draw a figure, basically you need to draw some lines. Okay, those lines must be very thin, and those lines need not be erased after finishing of the drawing. Okay, those lines are the thin lines. Similarly, projection lines. When we project the front view to top view or top view to front view, lines we need to draw. Okay, those projection lines must be very thin line. Okay, next, third line we will see dotted line or dashed line. Okay, dashed line. Dashed lines are used for representation of hidden lines. That means if we have an object and that object having a blind hole, that means hole up to some depth only. If we see that object from the front portion, that hole is not visible at all. Okay, in such cases, the invisible holes or invisible edges are represented with dotted line. Suppose, assume that this is wood having a hole here to here. Okay, and if we see the same thing in this direction, that hole is not visible, but that hole is there. That is the reason we need to show a dotted circle in the front portion. Okay, that means hidden lines, invisible lines, those are represented with the help of dashed line or dotted line. Now, the fourth one is long line, dot, long line, dot, long line, dot, long line. Okay, if we draw like this line is used to represent the axis of the solids or axis of an object. Okay, this long line dot. Okay, that lines are useful for the representation of axis of an object. Okay, now similar to this line, same long line dot, long line dot, long line dot, long line dot, long line. But the ends of this line, long line dot, long line dot, center line, if it is darkened like this line is used for representation of a sectioned line or the sectioned plane. If it cuts the solid, that line is represented with this type of line. Okay, next one. Suppose this is called as a zigzag line. Zigzag. A lengthy object is there. The lengthy object we cannot draw on the drawing sheet fully. The details which we are required, that portion only represented on the drawing sheet. In such cases, to show the continuity of the object, this zigzag line is used. Okay, for the engineering drawing purpose, these lines are enough. That is the reason I will close this types of lines here only. Okay. Next one, division of a given line into number of equal parts. Division of a given line into number of equal parts. Division of a given line into number of equal parts have a application at each and every drawing of a engineering drawing portion. Okay. Now we will take a problem. A line of length 115, a line of length 115 mm. We need to divide that line into 17 equal parts. Okay? 17 equal parts. Okay? In the problem type, a line AB equal to 115 mm length. Divide this line into 17 equal parts. Okay, now we want to solve the problem. First consider a line of length equal to 115 mm. This line we can name it as AB. This is AB line and its length equal to 115 mm. Now we want to divide this line into 17 parts. Okay, and those parts need to be equal. For that purpose, draw a constructional line. Constructional line is a thin line. This constructional line at any angle of inclination for any length you need to take. Okay, right. Now with the help of divider, take some length, any length. It need to be convenient. Okay. Likewise, first one division, second, third, fourth, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, 17 up to here. That means 17 equal divisions are considered on the inclined line or the construction line. Okay, that it be 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash, 13 dash, 14 dash, 15 dash, 16 dash, and 17 dash. All the divisions are equal. Now consider the last point, that is 17 division, 17 dash, and last point of the given line, that is B. Okay, draw a constructional line or a thin line in between these two. Okay, now with the mini drafter, draw the parallel line to this line through 16 dash, 15 dash, 14 dash, 13 dash, 12 dash, 11 dash, 10 dash, 9 dash, 8 dash, 7 dash, 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, and 1 dash. Okay, once again I repeat the point. We consider the last point on the constructional line or inclined line, that is 17 dash, and we consider the end point of AB line, that is B. We draw a line in between these two. Okay, after that, with the help of mini drafter, I draw the parallel lines to that line through 16 dash, 15 dash, 14 dash up to 1 dash. Okay, now we got equal parts on the given AB line. Let it be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, that means here this is a graphical method which gives equal division. Suppose if we analytically or with the help of calculator, if you calculate 115 divided by 17, it gives some fractional portion which cannot be measured with a steel rule. Okay, this method we can adapt in the engineering drawing wherever we required. Now we go for the other one, construction of polygons. Construction of polygons. Actually, in the mathematics itself, we know how to construct hexagon, how to construct pentagon, how to construct square, how to construct rhombus. Okay, all these we know. Okay, the same methodology we can use for the construction purpose. But here the orientation for the particular polygon that is given in the problem. Suppose if you consider a pentagon of side equal to 30 mm, and the pentagon one side makes an angle of 30 degrees with horizontal plane. In such cases, we need to consider one side of the pentagon with the horizontal 30 degrees. After that, based on that edge, we need to construct the entire pentagon. Now we will consider that problem. A pentagon of, we consider pentagon. A pentagon of side equal to 30 mm. Next one edge of this pentagon or one side of the pentagon inclined at one side, inclined at 30 degrees to horizontal plane. 30 degrees to horizontal plane. This is the problem given. Now we will solve how we can draw the respective pentagon. See, first draw a horizontal line. This is a reference line. Okay. This line is parallel to HP. That means this is a plane. If we consider a lengthy plane of infinity dimensions, in the front view it looks like a line only. Okay. Now with reference to this, consider a line at an angle of 30 degrees. Right. Now pentagon side equal to 30 mm. Mark 30 mm on this line. Let it be 30 mm. And this is AB. Okay. Now the included angle of pentagon, or the angle in between two adjacent sides of a pentagon, is equal to 108 degrees. 108 or 108 degrees. Okay, you can calculate. Suppose if you consider a pentagon, this is a pentagon, and this is the center point of this, and we know the angle at the center point equal to 360 degrees. Okay, if you draw radial lines from here, each one equal to 72 degrees. Okay, 360 divided by 5, 72 degrees. Okay, now if this is 72 degrees and this is an isosceles triangle, okay, therefore 180 minus in a triangle the total angles sum equal to 180. 180 minus 72 degrees, that is 108 degrees. Okay, and this is 72 plus 72, 108 degrees. Remember, you need to remember the angle of inclination in between two adjacent sides of a pentagon equal to 108 degrees. Similar analysis you can do for the hexagon also. Suppose if we go for the hexagon, the included angle equal to 120. Similarly, if you want to draw any type of polygon, the same calculation you need to do, right? Now, here you need to consider 108 degrees. Draw a constructional line, this angle equal to 108 degrees. And this angle equal to 108 degrees. This is 108. Now, AB length equal to 30 mm side. And all the polygons what we consider in the engineering drawing, those are regular polygons. That means all sides are equal, all angles are equal. Okay. Now, from B, 30 mm. With 30 mm, with the compass, we can draw an arc. This is C. Next, similarly for 30 mm, right? And now from C with B, with AB equal to 30 mm, the same length you can consider and draw an arc. Okay. And this point as center with 30 mm, draw an arc. Both will cut at this point. Let it be A, B, C. This is D. Okay. Now, here to here. This is E. Okay. Now we can say this is a polygon. The side of polygon inclined at 30 degrees to horizontal plane. Likewise, you can go for hexagon, heptagon, and square, whatever by the diagram given in the problem. Now, we will go for the other fundamentals. See, dimensioning is the one of the part in the drawing sheet. Whenever we complete the drawing, we need to show proper dimensioning at each and every figure, right? In the dimensioning, arrowhead is the one of the important one. So for the arrowhead, suppose this is an arrowhead and this length, if you consider as X, and this length, if you consider as Y, X is to Y must be 1:3 ratio. X is to Y. Okay, this length is to this length must be 1:3. Okay. And for this drawing sheet, that sheet number 1, we need to draw the arrowhead with a proportion of X and Y. Consider X equal to 6 mm and Y equal to 8 Okay, with that proportion, first you need to draw the arrowhead. Once you draw the arrowhead, then you can observe what will be the shape. Then you can remember that shape without taking the dimensions every time. You can draw the arrowheads for the dimensioning directly in the drawing sheet. Okay, now we will consider a simple figure and how to give the dimensioning we will see. Now this is a metal plate. And this metallic plate having a through hole at the center. This is a through hole. Right. Now we want to give the dimensioning for this object. Okay. Now these are called extension lines. These extension lines must be thin line, and this line length, let it be 100 mm. Okay. Therefore, draw a line parallel to this edge. If we measure this edge parallel to that only, it will be 100 mm. That is the reason, with the help of mini drafter, we need to draw a thin line. After that, give the arrows. Here I have not taken a ratio of 1:3, but already I practiced the arrowhead. That is the reason this shape generally, this proportion, it is obtained. That is the reason directly I consider. After that, I darken the arrowhead. Okay. Now above this, 100. This is 100 mm. We need to write like this. Here, see, when we draw a dimension line, at least 10 mm distance we need to maintain from the object line. Generally, students did mistake here. So with this line, very nearer to this object line, they drawn. In such cases, the student or any person not able to distinguish the object line and the dimension line. Okay, that is the reason. At least 10 mm distance we need to leave from the object line to the dimension line. And when it is horizontal, mention the dimensioning above the dimensioning line or text portion. And generally, the text portion at the middle of the dimension line, it is seems to be good. That is the reason centrally. Okay, and in nowadays software available, and the text matter may be written here or here like that. But it is a good practice when we write the text matter at the center portion, right? And these are the extension lines. The extension lines, for the extension lines also, at least 2 mm gap at this portion we need to leave. Okay, then only it will be good. Okay, and that extension lines after the dimension line also at least 4 mm. It need to be extended. Okay, then only it seems to be good, as well as it gives the clarity about the dimensioning of respective object. Now we will see how we can give the dimensioning of a vertical line. Now see, parallel to this, first draw the extensional line. After that, parallel to the vertical line at distance of 10 mm, draw the dimension line. After that, draw the arrowheads, right? And you need to darken. After that, let it be 50 mm. 50 you need to write like this. Right. Now, this portion, let it be 25 mm. Okay, if we want to draw the line dimensioning directly, you need to draw like this. Here also, I left a gap of 2 mm. Okay, now for the aesthetic sense as well as clarity, in the same line give the dimensioning. That is good, right? Next. Draw the arrowhead like this. And this is 25 mm. Right? Now, horizontal dimensions and vertical dimensions. Here you can see the total length 100 mm it is given, but this horizontal line dimensions are not given. Okay, for this, suppose if you give the dimensioning inside the object, here like this also you can give. But if you give the dimensioning inside the object, it hampers or it disturbs the clarity of the object. Okay, that is the reason try to avoid dimensionals inside the object. Now, for this, how we can give the dimensioning? Now, you can extend in the vertically upward direction, and now you can extend this vertically upward direction, right? And you can draw a horizontal line at a distance of 10 mm from the object, at least 10 mm. This is right. Now the total is 100. Obviously it will be 25, 25 and 50. Okay. Therefore, first draw the arrowheads. On the drawing sheet you can darken. Here every time I cannot dark here. On the drawing sheet you need to darken the arrowheads. Right. Now this is 50. This is 25. This is 25. Okay. Dimensioning vertical and horizontal. These are over. Now come to the dimensioning of the circle. First you need to draw a diametrical line through its center. Okay. After that, give the arrowheads at the end of the diametrical line. Okay, after that, draw an extension line like this. After that, draw a line like this. And here, the diameter, let it be 30 mm. Diameter is 30 mm. Generally, diameter in the engineering drawing is represented with pi. Okay, therefore, 30 pi. That means it indicates the diameter of this circle is 30 pi. Now see, all the dimensions are over. Here, what is the height of the respective circle, it is not there. And other one, the horizontal distance from this point to this point, what is the distance, that is also not there. Therefore, extend it, and this one, let us assume this is 25. Okay. Okay. The vertical distance is 25 and the horizontal distance. Here actually this horizontal distance first we need to note. This is let it be 50. Okay. Suppose for the this type of problem generally occurs while giving the dimensioning. That is the reason first you need to give this dimension. After that you need to give the dimensioning of this. Then it will be very clear. Right. These are the fundamentals. Now I will summarize what are the things we learn in the basics of engineering drawing. First one is types of lines. First we learn types of lines used in the engineering drawing. Okay. The second one, division of a line into number of equal parts. Division of line into number of equal parts. Equal parts. That is second one. Third one, what we learn, construction of polygons. Construction of polygons with the given orientation. That is the third one. Fourth one is dimensioning. Dimensioning. Okay. Now, this type of dimensioning, if we give, that type of dimensioning is called as aligned dimensioning system. Unidirectional system, aligned system, two types are there. Okay, this is called as aligned dimensioning system. Next, fifth one is giving text in the drawing sheet. Okay, text. Generally, for the text, also standards are there, but here I have not given much importance for the text, but only two things I want to convey. The first one is, suppose this is a square feet. This is a square feet. Okay. Now we want to give the title for this. Consider constructional lines of 6 mm. Okay, this is 6 mm. 6 mm. Okay, square feet. Directly you can write square feet. Okay. After that, give underline. Okay, underline this, the square fit. That is enough. Similar fashion with 10 mm for the titles, main titles. With 10 mm, you can write the text matter. Right? Okay.